Alright, so the last few steps involve using a 1 kilohertz sine wave with a peak to peak of 30 millivolts. And I don't have a function generator, so I had to improvise and use a op amp. And the closest I could get with a realistic sine wave was 10 kilohertz. And then to fine tune the amplitude, I had to use a trimming pot at the end, because if you lower the voltage of the op amp too much, it becomes unstable and you don't get anything reliable at all. But this is pretty close, so that's what I'm going to base my my circuit off of. And let's see, so we're essentially going to build this little circuit over here, which shouldn't take too long. Let's give it a shot. All right, so pin 1 goes around. Okay, pin 2 goes to a 100 kilo ohm resistor. I think that's a 100 kilo ohm. Yep. So 100 kilo ohm resistor. That's coming out of lead 2. And what's also coming out of lead 2 is a 100 microfarad capacitor with polarity negative towards the signal source, just like so. And then the other end of this resistor goes to power supply 1, which is going to be this. Which is going to be this right here. This is going to be power supply 1. Let's get that hooked up. Okay. And so that's this section of the circuit. Let's go to the top section. Lead number 3 goes directly to scope. So, all right. And then it also goes to a 1 kilo ohm resistor, which is this one right here. Okay. And then we're going to tie that into a 9 volt voltage source, and this is actually plus or minus 9 volts, so I'll just tap into this right here for that extra voltage I need. It's going to be just too short. Okay, and essentially that's the entire circuit, is this nest right here. And we're supposed to get, for VCE, which is right here on the output of the scope, we should be getting about 5 volts, and it says to tune this circuit based on power supply 1. So let's go ahead and do that now. Alright, let's see what we get. So we get about 1 volt. Okay. So it says get to be about 5 volts, however, I'm getting no, let's see, last shot at 10. Guess let's retune this one. Actually, I messed this up. I was tuning the wrong one. That explains a lot. Let's tune this one. That's a lot better. Guess that's as close as I'm going to get. That's close enough to 5 volts. Everything is looking pretty good. Let's get the scope on it and see what this looks like. So essentially, all this only purpose of this is going to be looking at the distortion. I think, yeah. So essentially what we're going to be doing is setting it up and messing with the, I believe messing with the input peak to peak, and we're going to see if I can get some tools out here. It'd be a little easier. Okay, so give me a second so I can read this over again. Okay, so this is pretty straightforward. This step and this step are essentially the same. what we're going to be doing is, after we've got this thing tuned to about 5 volts, we're going to see the max and min that we can have this signal amplify to before you start getting distortion. And then we're going to retune the same circuit to 6 volts and do the exact same thing. So this should actually be pretty straightforward and easy. Let's get the scope. Let it start warming up. Alright, so that's pretty hard to see. There's some sort of instability in my circuit, so you're going to see it go back and forth and wobble all over the place. And you're also going to see, I believe, when you're seeing the lap over, it's getting a little harmonic frequency in the cable. But we're just going to have to deal with that for now. Essentially, we're at around 30 millivolts. And let's see what the output is. Let me get some more leads. Okay. Let's okay. Ooh, it's all over the place. Let's do our best to try to... Okay, so it is an inverting op amp, and it's amplifying, not op amp, it's a inverting amplifier, and it's amplifying it quite a bit. It's going from about the 30 millivolts to about 3 volts, which is quite a significant amplification. You can already see some trimming on the top and bottom, but I have a feeling that's actually my wave. I don't think that's the transistor trimming it. So let's see what the min and max is for this amplification. I'm going to say that is probably going to be the maximum. So that's about 4 volts peak to peak on the output, and that's about the max that I'm getting here. If you had a real nice sine wave from a function generator, you could probably get better than that, but as you can see, it's getting pretty distorted on my end because of my imperfect sine wave. So let's say the maximum is 4. See what the minimum is. All right, well, that's the minimum that I can trim it with the trimming pot, and the wave that's going in is about 2 millivolts, and then the wave coming out is about 2 volts. So let's just say 2 volts, peak to peak. Okay, so now let's adjust it to 6 volts on the output. Okay. Again, that's going to have to be as low as I can go. However, there's more distortion, I think, in this sine wave. It's really hard to tell. Oh wow, that sure jumped quick. Again, that's about 2 volts. Let's see what we can get in the max. You know, it might be easier if I just separate these. So that's pretty heavily distorted. Let's bring it back. And with my, well, okay, let's see. I'm curious if they mean trimming as in wave distortion. Well, it's kind of hard for me to read right now, but let's see if it starts cutting the top of the wave off. Because even though mine is heavily distorted, the wave itself isn't. Alright, so that's cutting the top of the wave. So that's about the maximum, and we're getting about well, we're getting 3 volts. Again, maybe 4. That doesn't sound too correct. Then we're back down to a little under 2 volts. And that, so I'm gonna go back and revisit the other. Let's see. Let's bring this back to 5 and see what we get. Let's use this, the 4.6 volts. It's climbing a little bit, so it'll be close to 5. Let's see what's going on with that one. Again, you can visibly see some distortion in the waves. And we're getting the same amount of amplification. It starts getting pretty unstable when it gets, let's see, it's dead on 2 still. About 6 volts, it still gets pretty unstable. So maybe let's change that to 6. Just curiosity, let's get it looking normal and then just mess around with the voltage. Alright, that looks like a pretty normal waveform. Now let's get the meter in here again. Okay. More sense. Let's bring the voltage, that's as far down as it'll go. And as you increase the voltage, well, no, as you decrease the voltage, which makes perfect sense, the amplification pretty much goes away. You can see where it's shifting. And let's see, 1 point. I would have thought that'd be around 0.7 volts, but that's double that. But yeah, you start getting a wave once you start cranking up the voltage. And this maxed out, I'm only getting 5-ish volts. But anywho, it's slowly climbing. So something. Oh, my negative voltage regulator is getting pretty warm, so that op amp must be really limiting my circuit. But anyway, there you go. It's pretty interesting. I wish I had a nicer sine wave to put into this thing so I could get better results, but I guess I'm going to get a function generator sometime in the future, and then I'll be able to really make some serious measurements. That's it.